Alright, so on this video, I'm going to do problems 3, 4, and 5 from your test review. There'll be a couple other videos with various other problems as well. If you need to see any other problems worked out, check the key that's posted on Canvas or ask your teacher in class for some help. Alright, so number 3 says the per unit cost in dollars of producing n items is given by this equation. Now, it wants you to algebraically find the minimum cost in items that need to be produced to create that minimum. Now, whenever we're asked to find the minimum or maximum algebraically, you need to use this formula. X equals the opposite of B over 2A. Now, in this situation, our X variable is being represented by N. So really, we have N equals the opposite of B over 2A. Now here, the opposite of B is 195 over 2 times 0.125. So you just go ahead and type that right into your calculator. I'm going to make a fraction here to make sure that everything works in terms of order of operations. 192, I was right, over 2 times 0.125. Oop, no, I was right the first time. It's 195. I'm so sorry. Let me type that again. So I have 195 in the numerator divided by 2 times 0.125. All right, 780 is the right answer. Now that 780, is the N, the number of items. That's over here. So this company can produce 780 items, and we need to find now the cost for that minimum number of items. So the way you do this is you're going to put that 780 back into the function for N. So you'll have 0.125 times 780 squared minus 195 times 780 plus 77,325. You need to very carefully type that into your calculator to find the cost. Right, so I'll have 0.125 times 780 squared minus 195 times 780 plus 77,325. And this is the cost that it takes the company to produce 780 items, $1,275. So the key to this problem is remembering that to find a minimum value, you need to use the formula opposite of B over 2A. All right, now we get to our challenge problems, 4 and 5. So number 4, it says in physics class you were launching marshmallows into the air to learn about velocity. You launched the marshmallow from a height of 3 feet and know that the marshmallow got to a maximum height of 6 feet after 2 seconds. Write an equation in vertex form mapping the path of the marshmallow. Now, the first thing you need to know is that you need to know what vertex form looks like. And here's the basic format of vertex form. Now, in order to solve this problem, we need 2 things. We need an ordered pair, and your ordered pair is going to be an x and a y value, which we'll write here in just a second. And you also need the vertex. That's going to give you your h and your k. So we'll write our vertex here. All right, so we need to find what is the ordered pair and what's the vertex. I think the vertex is the easier one to find here because it tells me that the marshmallow gets to a maximum height of 6 after 2 seconds. So my vertex here is going to end up being 2, 6. The time is the x, and the height is this y value of the vertex. All right, so that vertex is going to be really important to us in a minute. The ordered pair comes from the other numbers that we know. We know that we're launched from a height of 3 feet. That means the marshmallow starts at a height of 3 feet, which is the ordered pair 0, 3. Now, what we have an x, a y, an h, and a k, which are going to go in for x, y, h, and k in our basic vertex form. So let's substitute in what we know. For y, we know that y value is 3. So we're going to write 3 equals. We do not have anything for a. We're actually going to solve the equation for a. In parentheses, our x here is 0. Now, it's the opposite of h, and our h is 2. So minus 2 squared, and our k over here is 6, so plus 6. So what you're going to do is you're going to solve that equation for a so that you can write your equation. So let's simplify. 3 equals a times, well, 0 minus 2 is negative 2 squared, which is 4, plus 6. Now this is 4a. I'm going to rewrite that as 4a so you don't get confused and add the 4 and the 6. And all you have to do is subtract 6, which gives you negative 3 equals 4a, and divide by 4. So the leading coefficient on this vertex form is negative 3/4. That allows me to use that to write the equation. Y equals, well here my vertex, or my leading coefficient is negative 3 over 4. And then inside my parentheses, I go back to just an x for vertex form, minus 2 for the turning point that I know, squared plus 6. That is the equation of my path of the marshmallow. Now the question is, when does the marshmallow hit the ground? And I can find that now by using the equation that I just wrote and typing it into my calculator. So we're going to go back to our calculator and we're going to go, to y equals. Now in the y equals, you're going to type your equation. Right? So we have negative 3 over 4 times x minus 2, the quantity squared, plus 6. And you're going to graph it. You can see where the parabola is going to hit the ground, or where the marshmallow is going to hit the ground. So we're going to trace, which is hitting the ground, is the 0, the x-intercept. So you bring your cursor way over. It takes a little longer on the board here. Whoops, there we go. A little above, we hit enter. A little below, hit enter again, and guess. And it looks like you hit the ground after about 4.83 seconds. All right, so that is the answer for the last part here, 4.83 seconds. Okay, so that's I like that kind of problem, writing vertex form, writing the equation from some information. Now here's the real doozy on the review, this challenge question. Right? This is a good one to understand. It's very similar to a calculus problem, if you know anyone taking calculus that they've been working on in the recent past. But it's a little different than stuff we've been doing in our class. So let's work through this the best that we can. It's a little bit challenging, but understanding it in general is beneficial. You should also make sure that you understand all of the box problems that we have done in this unit. So we've done some on our quizzes and our practice and notes in terms of finding area of boxes. Understand all of those. All right, so it says a rancher wants to make 2 corrals for his animals out of 100 yards of fencing. This shape is the shape that he wants to make for his corrals, his fenced-in area. All right, the rancher wants to maximize the area of the corral. We'll come back to that in a minute. What dimensions should he use? Well, let's draw on our picture at least the information that we're given and what we know. We know, I'm going to call this length right here W. So this side is W. Well, these 2 vertical lines are also the exact same distance. So I'm going to call all 3 of those the width. And then this top part and bottom part are also the same distance as each other. I'm going to call those the length. Okay, the length and the width of the corral. Now we know that all of those sides added together have to add up to 100 yards of fencing. So we can at least start by writing the equation 100 equals. Well, if I add up all those letters, I'm going to have 3 W's plus 2 lengths. And that gives me the perimeter of the fencing for these corrals. Now, the next part of the question, what we're actually looking for is we're trying to find the maximum area. So somewhere here, I need to bring in my area formula, which remember the area of a rectangle is length times width. Now in order to make this happen, I need to solve this equation I just wrote for one of the letters. It does not matter which one, but I need to get one of the letters so I can use my formula with just one variable. Okay? So what I'm going to do is I'm going to solve this equation for, I'm just going to choose L. You could solve for W and it would work just fine. I'm going to solve for L. When I solve for L, first thing I need to do is move the 3W to the other side so that it moves away from the L. So I'll have 100 minus 3W equals 2L. And then I'm going to divide by 2. Which tells me that I'm going to simplify this. You don't have to. You could leave it as this fraction form. But 100 divided by 2 is 50 minus 3 over 2W. That's the length in terms of W for either side of this corral. Now what that length gives me, or allows me to do, is I'm going to take that value, that equation I just wrote, and I'm going to substitute it into the area formula for L. Because look what happens when I do that. When I substitute in, I get A equals, right? So instead of L, I'm writing 50 minus 3 over 2W times the width. I have one equation with just width this time, one variable. And I'm going to now use that equation. I'm going to graph it and use it to find the area, the width, and the length that I want this corral to be. Now you are welcome to distribute here if you would like and get rid of the parentheses. However, I think it's fine just to leave this in the factored form. Okay, so to start, I want you to type that equation into your calculator and use the window setting in the box that I gave you. I tried to help you out here. So I'm going to pause the video and type that in, and then when I come back, everything's going to be set for me, okay? All right, now, when I look at this picture, I have set the window. This is what the graph looks like. Make sure when you type your equation in with a fraction that the x is not in the denominator of the fraction. Otherwise, you're going to get something really goofy. But here's our graph. Now, what I'm looking for here, again, remember, I'm looking for the maximum area. So that means I'm going to be looking for the max of this parabola. And I'm going to write that right over here once I find it. The maximum is at some value. Okay, so I'm going to trace it. Second trace, I'm going to choose maximum number 4. And I'm going to come a little to the left, a little to the right. Here we go. It has the ordered pair 16. I'm going to go to 0.67, or 16.7 about, and 14.67. Well, 416.67. Okay, so that's your ordered pair. So 16.67 and 416.67. Now, from that information, we need to be able to interpret the ordered pair. Now, remember, your ordered pair is an x and a y. When I look at the equation that I graphed over here, the letter that's acting like the x is the width. So this x value is the width of the corral, 16.67 yards. That's how much, how wide all these W's should be in the picture for the rancher to make the biggest pen he can with 100 yards. The y value from that ordered pair, well, the letter A is acting like the y in the formula. That's the area. So the maximum area that this rancher can get is 416.67 yards. So from there, I'm able to find the length of the pen. And to do that, you can use either one of your formulas. Why don't we just use this formula right here that's already solved for L. All right, so we have L equals, we'll take 50 minus 3 over 2 times the width. And we said the width was 16.67. And we're going to have an approximation because we rounded that answer, but it'll be close enough. Okay? So let's type that into our calculator. 50 minus, I'm going to make a fraction again just to be careful, 3 over 2 times 16.67, which gives me 24.995, which is just about 25, which is the exact value. So the length is going to be 25 yards. I'm sorry. Right? That is a challenging problem. There's a lot to it. Hopefully you understand a little bit once you've slowed down and then listened to the explanation. All right, so that's the first video for the review. There's going to be 2 other videos with a couple other various problems.